Ooh. Thanks, Dare. Hello, everybody. I think we should finally be live. Let's see here. Let me make sure everything turned on properly. Yes, looks like we're good. Okay, so sorry about the quite late start there, but we're finally ready to go now, and I think we should have some interesting stuff this week. So, let's see here. So this is part three of the numpy bug hunting that we've been doing. We did last Saturday. Spent about 3 hours trying to build a test harness and a fuzzer to take a look at numpy. We got that up and running. We found a few crashes with it and looked pretty cool. Then on Monday, we went back, we changed some things, we fixed it up a little bit more so it would actually work well and so we could get a ton of output. So the first version we put together back on Saturday, it worked, but barely, and it had some major problems with it. It wasn't actually able to find the bug that started all of this, which was a resize of a numpy array. Because of how we were generating scripts, we couldn't actually find the thing that we were trying to find. So on Monday, we fixed all that, we got it up, we got it ready, we deployed it to EC2. And so we had about 48 hours of running on EC2. Oh, nope, that is the wrong window. Go back over here. Okay. CD crashes slash EC2. So, how many crashes do we have? We have this many crashes. In fact, we have 7,593 unique crashes. Well, 7,593 crashes. We're going to have to actually do some work now to determine, are these unique? What do they look like? And just to pick one out here at random, this is actually at random, I haven't looked at this at all. If you didn't watch on Monday, this is what these crashes look like. This is the output from our test harness. And I should be able to go to print 10, this print 10, and I believe this one right here. It should be the one prior to it because there's bugs in our test harness and all that. Also, and this is a little important, I'm trying to think of what order to do this in. Yeah, you know what? Let's go fix this bug real quick. So we didn't go over this, but while I was going back and I was reviewing all of the code and seeing what was going on, I realized that there was actually a pretty critical bug in our test harness. So again, just to review real quick, the way this test harness works is we have this C code which gets loaded into Python. We call init on it. That sets up a big buffer, and we pick a very large buffer like this so that it gets mapped in by malloc. So it's not going to be contiguous with the rest of the heap. Just in case Python uses that, we want to be completely separate, and we want that all to work. So we mmap that, we set it all up, and then for every test, we're going to copy in the function that we're going to test. Seems good enough. And then if we ever catch a seg fault, we're going to print it out and dump it out. Now, the problem is, and it's kind of amusing because if I remember correctly on Saturday when we were writing this test harness, I said, so we're using stir copy here, and that's not going to be a problem because we know the stuff we're inputting it should be safe. That's not actually just true. That's not true at all. In fact, so I did some other testing, I believe yesterday. I was just poking around with some other modules. I wanted to get things working. And I found something very strange, that I was getting a whole bunch of seg faults recorded that started, that were all not reproducible. So I was running these, it would run for a little while, it would catch a seg fault, and it wouldn't be reproducible. So I had to investigate it a little bit, and what was happening is, and if you look at this code, you might catch it real quick. If we were on the 32nd iteration in this circular buffer, and the function we were testing was over, what is that, 8,192 bytes in size, we would actually segfault because we would run off the end of the page we had allocated. So the short version here is this is a bug, it's bad, and it caused a whole bunch of problems for me in something else I was testing. Unfortunately, I don't have a really good way to stop this. In numpy, we basically solved it the easy way we just never generated functions that were long. We couldn't with how we were doing things. But for some other things, that might not be possible. Now, I don't have a really good solution for it. One of the options is we can just... So memory's cheap. We'll make plenty of space for it. And let's go through, and we're going to do a str_n copy. And we're going to bound this. Now, this works fine. But the downside here, and this is actually a trade-off that's really important to consider, is when we're doing fuzzing, we're intentionally creating inputs that are not expected for the program. And one thing that happens to people a lot when they're fuzzing, and if they're doing good fuzzing, what tends to happen is when they get crashes and they get interesting inputs, a lot of the time they're surprised because it isn't exactly what they expected. They're a little bit surprised that the fuzzer generated a thing that looks like that. And so the problem here is there is a chance that we will have the perfect, absolutely exploitable bug, but because of how we're logging it here, we're going to lose it. And I don't have a good solution for that because in this case, our case is going to be, well, we're just going to limit the amount of space we can have, which will work. But it means that we can never generate some massive chain of functions. And it's possible that that's the only way to catch whatever bug there is. Unlikely, but it's possible. So, at least for now, this is the solution I'm going to go with, and it will just work. So, hopefully it compiles. Yeah, there you go. That's that. So we have taken care of that. I have done my public shaming, and we can all see that I am... C is very clearly not something I am an amazing author of. So with that said, let's see if we can reproduce one of these at random. So I want to do import numpy as np, and assuming that everything works properly, I should be able to do... So we instantiate... so we call this function, which calls this function. So we get a uint16, np.uint16 sum. We call that with a tuple. We then take the class of that, and we call that with np... No. Yeah. Wow. Okay, so np.long double np.uint16 view as a dictionary. Module has no... Oh, I typoed that a little bit, didn't I? Invalid array struct? Yeah, so responding to the chat here, yeah, giving it more space. Memory's cheap; it'll work. And right now I'm limiting it to 40,000 hex bytes, which is a ton of bytes. But again, it's possible that we're going to run outside of that, and we're just going to live with that. Set no new. We're just going to copy this one. Right up. Control escape. Copy all this. Oh, why didn't you like that? CD. Yeah. I'm not sure why it's still not working, so we're just going to write a script to do this real quick. No, we need to go repro p.py. Oh. but no. Oh, I can't type. Python repro_t.py. NP. Python interpreter doesn't like multiple. There we go. That's what we wanted to see. So we got our Python to crash. And so in theory, I should have about 7,500, 7,600 examples of scripts kind of like this, that when I run them, Python is going to segfault if I parse them out properly. One thing to note, in case it wasn't clear, so the reason we're doing things this way, so the reason why we're logging out all of these is because I don't want to lose state. It is possible, so as an example, suppose we're getting heap corruption. We're writing well outside of the bounds of some heap allocation. Most of the time, that's not going to cause a crash. It's going to corrupt the state of things, but it might not cause a crash. So let's say there's some numpy struct that's allocated for the module itself, and we're able to write outside the bounds of that. When we write outside of the bounds of that, it's perfectly fine until we do some other heap stuff that eventually causes a crash for us. So that's why we're logging all of these out. The downside is that all of these are, what's the word I'm looking for? They're all fuzz test cases. So for the most part, they don't even parse properly. For a whole bunch of these, if we tried to run them, so if we tried to run case 8 right here, I don't know this for sure, but it's quite possible that it won't even run the way that it is. Python is going to complain that there's an invalid number of arguments or something like that. So we're going to have to write a parser to actually pull all these out and test them. But let's take a look at this real quick, because why not, right? Maybe we got super lucky. But I suspect this is the same one that we saw before. Yeah, there's this case, and I still don't know exactly what it is, but there's a case that we've run into before, which is a null deref. Well, it's not quite a null deref. So it's we've got this RSI plus 08, and it's an offset of usually, I think most of the values we saw were OXEB in our SI, but it's a very small value. So this is probably some offset into another struct that we're trying to get to. Yeah, we're gonna probably change everything to that. But we're gonna have to, basically, the first stage of what we're gonna do here is we have all these test cases. We're going to take all of them. We're gonna write some more Python here. Actually, we can do some notes here while we're at it. repro notes.text. So we're going to, why is file system access taking a long time? Shouldn't be. But we already did show test case. We're going to write parser for repros. Categorize everything. So I'm not sure how we're going to do things when we get to stage 3. There's a few different things that we're going to have to do. So for example, we might want to run them all through GDB and categorize them based on PC when we get the crash. If they're all in this pydict get item function, it's possible that they're all the same thing. Seems at least somewhat unlikely, but it's possible. We're also going to want to categorize them based off of what is actually being done by the Python. So there were some other cases that we looked at briefly on Monday, which had the same view dictionary construct, because for whatever reason, that's come up a few times. However, what's interesting here is that we aren't getting the crash when we do that. So if we look at the code here, the way that the fuzzer generates stuff, it means that this on its own works fine. We can call, in order for this code to be generated, it means that the inf432fd blah 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 has to return something that's valid. If it doesn't, then it won't get added to this list to work in the future. So this view on its own is fine. It's somehow when we pass it to this the call to class that actually tries to access something that's a problem. So we're gonna have to turn up exactly what's going on, and it's at this point I don't know why. We're gonna have to actually get around to that later. But that's something for a later date, right? Well, hopefully later hour that actually get to it today. But let's get started with the parser. We can start that right now. So that's what those look like. Cd into Python, make repros.py. So what all do we need to do? Yeah, this one will work. /crashes/ec2. Actually, let's do a make.dir repro ec2. And we're going to import OS and Python cd ec2 Python import or Python. Sorry, import os.listdir, I believe is what I want. Yeah, that's what I want to do. So for file in os.listdir /home/sam/crashes/ec2 if file, oh, right, we should not overload that, that would be bad, or if 5 characters is equal to crash, or it's not equal to, we're going to continue? I believe that's the right word. Otherwise, we're going to open it. So test case is equal to open f dot read. So print test case. Let's print out the first, bunch of bytes, and we're going to just exit. Right? Yeah, that looks good. So we're going to go over to 2. Python make repros. No such. Hey, we did not put it there. Sorry, that was the directory on the EC2 instance. It is in projects/crashes. Okay. Oh. /home projects crashes ec2 plus. There we go. And of course, if I was doing things properly, then I would, actually do some what is it? The os.builder or that stuff. But so we have this. We're gonna do cases is equal to testcase.split. And so because of how these are generated, right? We still have one open, don't we? Oh. Let's just open one. I want to. No. What do we do? I accidentally. cd crashes, cd ec2 vim crash ox7fff. Jeez. Okay, so this is one. So if we split on print, we should have things reasonably close to what I want. And so for case in cases, print case, we're just going to print the first, some number of bytes of them. Why is that one broken like that? In case, we get basically what I want to see, right? That we have a whole bunch of these, and that in this case, we were currently on 31. So if we get the negative 2th element, yes, the negative second element is probably the word I actually wanted to do. Likely is equal to cases negative 2. And likely is equal to, you know what, let's just do it this way. Print plus. And so we're just doing this to, because we stripped it out when we split it. We're going to put it back in. What I expect to see here is if we do an exec likely, comma, np, we're going to import numpy as np. Right. So if all this works the way that I expect it to, I should get a seg fault. Oh, well, it helps if I can type right. That is indeed a seg fault. So, that does basically what I expected to do. But we need to go a step further. We can't just do it this way, because we can't have the Python we're running seg faulting. So what we need to do here is we need to split things out. So instead of looping through and setting it up this way, we're going to do fname is equal to that process Python test repro.py fname shell is equal to true. Let's actually capture this. So s is equal to that. And we need to do from pwn import star. You can tell that I play a lot of CTF because the way that I run processes is by importing pwn tools. But, so we have that. Set no new. Test repro.py. Oh, enum w test repro.py. There we go. Oh yeah. So the sum thing right there is probably from one of the other cases. Well, we'll go through and get them. Right now, all I want to do is I want to see if they do or do not reproduce at all. Because there's a decent chance that some of these aren't going to reproduce at all, and I'd like to know that sooner rather than later. Import sys? I think it's sys. Fname is equal to sys.argv1. Fname. I think it's right. So, Python. Right, let's start by doing ls crashes ec2 head Python test repro. We want, because I actually need the full path here, /home projects Python or crashes ec2. Yeah, okay, so that totally works the way that I want it to work. And now we're going to be buff1. We're going to be absolutely gross about how we do this. And we are going to do s.clean Now, this is not the right way to do this. What is the right way to do this? You know what? Test it and see. Python make repros, and we're going to do a -I here. So s dot clean5 works fine. S is still a thing. S dot an exit code of 1? What does that mean? What does it exit code of 1 mean? Okay, I guess we're going to try this and see what happens. So we have this. Yes, Python test repro. What did it say it was an exit of 1? Of 2. Want to exit 0. Wait, that seems weird. Oh, no, come back here. It's just that I don't get a core dump too. Manually mint my. Yeah, I suspect most of the cases that we're going to find here, and hopefully that's not the only bug we found, which was views to dicks causes problems. But we'll see as we go. Ideally, what we're going to do here is we're going to go through, we're going to check to see which ones reproduce, and do some basic classification here. And based on what we get, we're going to dig into the actual source code and see if we can at least root cause 1 or 2 of these. Hopefully we can do that tonight. But, so where was I? This worked fine, and we want s dot exception? No. So I'm pretty sure I know there's something. Man, I cannot believe that I can't remember what this is. There is something I can call here to see how it exited, but I don't remember how to do that. Can't believe I am completely blanking on how to do this properly. S.wait close. Maybe. Like, this is bad. Like, I have done this before, and I can't remember how I did it. You know what? We can do this the other way. Because while import process, import subprocess dot check output Python test repro, that thing shell is equal to true. So this I can do the way that I was kind of doing it earlier. Not exactly the way that I want to be doing it, but come on. Where did I know I was writing code someplace. Oh, there it is. Wow. That is quite the way to do it. I think doing it this way is a little bit cleaner. Import subprocess. Try subprocess.check output Python test repro.py plus fname, comma shell is equal to true, except. So if we get our exception, it means that this is a reproducible test case, because it means that subprocess was not able to get a return properly. It caught a crash. Print %s reprod. We then want to do an os. I can do an os.move, right? B. os.path, os.path dot. How do I move something in Python? Seriously? Man, today is not good for me showing off my deep knowledge of how to do things in Python. I'm going to see a lot of %s reprod. Yeah, I'll fix that in a second. Python move file. How to move a file in Python. Oh, os.rename. Of course, that's what it's called. %fname. There you go. os.rename fname. Yeah, we can just do it this way. /home/sam projects crashes ec2 repro. It's this one. Crashes repro. Oh. Helps if I call things the same thing on both sides. So I think is a directory. os.path or os.path. Oh, wait, I can just do it this way. Plus F. So that will do what I wanted. What is that? They're good. What is going on here? Sorry, everybody. It's interesting how many of these are not reproducing. So the ones that are causing exceptions means that our super naive way of doing things isn't reproducing. No. But we are getting plenty to reproduce, which is good. It's actually a little bit more than I expected to reproduce. I kind of expected a lot of these to fail reproduction for various reasons, but I'm particularly interested in these that are reproducing, and yeah. This is why you're not supposed to do things this way. Like when you do a try except all, if anybody reads your code, they're usually going to say, why are you doing that? That's a terrible thing to do. I do really like that abort we just saw pass by, though. Go take a look at this real quick. What is this? Yeah, corrupted doubly linked list. I like the looks of that. I have a lot of files that do not reproduce now in the reprod folder. So I think we should, yeah. I'm not sure if we'll have those or not. I think when it was catching the control C, it was catching it most of the time in the sub process, because that's where it spends most of the time. At least I hope that's the case. Hopefully that's the case. Super excited about this one though. This corrupted doubly linked list looks super exciting. It looks like that's the kind of heap corruption we were hoping for. Because this was actually a... like, that's in the garbage collector as it was trying to clean things up when it was exiting. That is exactly what I was hoping to see, because hopefully what that is that is actual, like, just a straight out of bounds write. That's super exciting. But you know, the more that I think about this, the more that I think that I'm doing this entirely wrong. Because if this reproduces, I want to minimize this as much as possible. I don't want to have this massive file, because if it reproduces, I don't need it. I can just take the part that reproduced and go from there. So what I'm going to do is we're going to come in here, kill all Python. Bye-bye. We have that. And now I'm going to come in here, and these are going to go away. So move, I'm going to make dir all, move EC2 to old, move repro to old, make dir EC2, find EC2, dash name, star.py, exec, move to EC2. Now, I want to find it in old. Dash name, star.py, dash exec, quick check likely. I'm actually familiar with what quick check is. While this is running, I'm going to go take a look at that though. Once we get all this set up and it's actually producing stuff. Quick check like library structure for Python function. There we go. That looks like what I was hoping to see. And I should be able to then do 0. 0 is where we're editing things. So we don't want... If it reprod, let's think about this for a second. So if it reprod, then it means I should be able to do open fname.read case is equal to that. Crash is equal to, was it case.split print -2. We should be able to do a write to /home project crashes EC2 repro plus F. Oh, no. We want to write to a thing. We need to open it. We need to open it writable. And then we write crash to that. Print plus. I think I moved the files. Pretty sure I moved the files. Yeah, it looks like the right number of files. So the good news is that I still have them all on the EC2 server still. I do have copies of them. So even if I completely broke everything right now and my laptop caught on fire and everything went away. I still have all the crashes, so we're good there. But we have that. We are now doing it this way instead. We're just taking just the part that caused a crash, and we're going to print %s reprod %. That looks good. So, make dir ec2 repro. Oh. Paths are hard, aren't they? Okay. So this is running. This is going to go find all of our reproductions. That sounds great. So quick check. What is quick check? Automatic testing of Haskell program. Ooh, Haskell program. So for people who are watching this video after the fact, Animoe mentioned that this would be something good, and I have no idea what this is because I tried to learn Haskell for a little bit, and I actually had a lot of problems trying to get anywhere useful with it, more than anything else. He didn't solve any of the problems that I was having, so I stopped trying to pick it up. And at this point, I think I've forgotten all of my Haskell. In QuickCheck, the programmer writes assertions about logical properties that a function should fulfill. Then it attempts to generate a test case that falsifies these assumptions. Once such a test case is found, it tries to reduce it to a minimal failing subset by removing or simplifying input data that are not needed to make the test fail. Yeah, I suspect what we're going to end up doing, apparently there's an implementation for Python actually, but I think what we're going to end up doing is once we've tested all these for reproduction, the next step is to run all of these through GDB, and we're going to classify them based on what PC they crash on. And hopefully, once we've done that, we should be able to... So that's not perfect. There are cases where like we have two unique bugs that still crash on the same program counter. But I think it gets us most of the way to where we want to be, because it does let us understand a lot of what we're looking at in terms of what's actually probably going to be a very large corpus of files. So ec2 repro, like we already have over 600 that reproduce and coming in here. Now, the good thing is that each of these should be much easier to look at now. What? That is not what I want to have happen at all. Why did it do that? Are they all like this? They're all like this. Crash, we're taking the -2th index. This should work. Not quite sure why it isn't. F is equal to open that dot read. And it was right here that we were looking at. So print plus f dot split print 2. That is what I expect to see. Why is that not what I'm seeing? Am I running the wrong version of the code? That would be the worst. Well, not literally the worst. That's, oh. Or maybe I'm just being dumb and I'm looking at the wrong directory. There's that chance too. Hmm. This is exciting. I think what's the best way to go through this now? These are reproducing. They're doing basically what I want. That I should be able to go Python, that thing. Oh. Damn it. Okay. Let's think about this for a second. So we're not removing them anymore, which is good. So, right? We're not moving them anymore. So we should still see ls e2 pipe wc. Yeah, we still see the same number. So hello Python. We don't want to just print. We want to do import numpy as np, then print. This now does what we actually want to do. rm ec2 repro. We're going to make sure we do this correctly this time and not lose everything. Please don't die. Running commands like that always makes me super nervous. Like, it makes me feel like I'm going to mess it up and I'm going to lose everything and I'm going to feel bad forever. But that looks like what I want to see, right? That's exactly what I want to see. So now that we have this working, we need to do some classification of these. Let's think about the best way to do classification here. The last time we did classification, this will put fixed versions into a new folder. The last time we did these, we just did some crappy GDB scripting, which I think might be the right way to do it this time too. The downside is we have a whole bunch of these crashes. So it's going to take a little bit of, post-processing. But if we do gdb -- args, bang, bang, we're going to run this thing, we're going to run it, print $rip. That looks pretty reasonable, right? And print. Really? Go args. Okay. So I believe we should be able to then put a really simple script together. So for, let's go in here. Vim rip classer.gdb. We're just going to run it, or I'm sorry, what is the? I believe it's, you know what? We're just going to run it. Set logging on. I believe that's the right command. Then we're going to show args. So I'm trying to think here. Do I want to print out what the program counter is, or do I want to print out the arguments first? I don't think it matters too much. Print. I think it's the direction I want to go in, though. So we have this man gdb dash batch and dash e, right? Dash x. So dash E, no, we want dash X, don't we? Where is it? Dash X, yeah. So dash batch, we'll get rid of a whole bunch of the junk we don't care about. And dash E, project, Python, rip, classer dot. Okay. Oh. After I just sat there and said, it's not dash E we want, it's dash X. No such file or directory. No, there's an underscore in it. That looks good. And so there now should be a gdb.txt in the current directory. That isn't quite what I want, but I can live with it. Ideally, this would all be a lot quieter. Hopefully, so we're also going to pass dash batch to this. Text. You know, it's a little bit more text than I really want to see, but I can totally live with that extra text. So I'm going to go into our Python folder again. What were we running to do this? This. Classer.sh find /home projects crashes repro dash exec. Oh, do this right. Dash exec that Python file name. I think that's what we want. Well, thanks for coming out. I will probably, hopefully, have some results to post. And feel free to watch the video whenever you get around to watching it. And like I said, thanks for waiting for me. I do appreciate being late like I was. So thanks everyone who was able to watch. And I'm going to hopefully get a little bit farther here. Hopefully we have some cool results that I can tweet about and talk about and tease people about how awesome it is. We'll see. And now we work. Ooh, that looks so nice. I'm so happy that I just saw that. Like, we have an example now of that heap corruption, and I cannot wait to see what it actually looks like. Wait, I'm being dumb. It's a computer, it can do multiple things. You cat gdb.text pipe to unique. Oh, sort. Now. So sort rep dash v exterior rep argument. Okay. Pi string from string and size. But I think this one's the one that I'm really excited about. So vim gdb.text, go find one right here. We had arrays, and the way that we raised it was we used this one right. Projects crashes EC2 repro. Oh, This one. So this, whatever this is, apparently is going to cause all sorts of problems when I run it. So home projects, crashes, repro, that thing looks so nice. Like, it really does. I'm so happy when I see an assert like that. Because it means, like, this very clearly tells me that I totally have heap corruption, right? So when we were in main, for whatever reason, we're printing an exception. And in the process of it, when they're trying to do fgetS, malloc eventually finds that it has a corrupted doubly linked list. And that is super classic. Oh, look! That's some heap corruption right there. So now all we have to do is try and figure out what the fuck caused that. Before I get too far. Ooh, we're getting some more here too. We're getting crash. Ooh, we're getting crash and free, which is probably might be the same heap corruption. And there's at least one. There's a few in there. The mem copy is super interesting. I wonder what that mem copy is. See, this is the part that's going to be a little difficult. Is we have quite a few crashes now that we can take a look at. Let's go over to 5, 6. CD repro. Vim thing. Wait. So this is apparently causing a Python of that thing. pdb --args bang bang. Now, I was super excited when I saw that, right? So this is what it looks like, and we're getting crash in mem copy. So what I was really hoping for was that we got incredibly lucky and we found a crash which was just throwing A's into a pointer that was going to get mem copied someplace. But it would appear we are not that lucky. The source of what we are copying from is a 1. Is RDI right? X RDI. Apparently RDI is actually a valid value, but this looks like it's probably just a null deref, which, you know, while I'm not going to, definitely not going to, what's the word I'm looking for? Poo-poo a null deref. There's still, entirely possible that this is still, like, that's still an exploitable bug. So, hello, Max. So what we're doing right now is so on Saturday we started doing some fuzzing of numpy, the Python, it's one of the Python modules for doing mathy stuff. So on Saturday we started fuzzing it. On Monday we made our fuzzer not a piece of shit. Well, it's still pretty bad, but not complete dog shit. And then today we're actually starting the process of classifying the crashes we got. We've got, it looks like at the very least we have 1, 2, 3, 4, 5, 6, 7 unique crashes. But we're still running through. So over in this top left window is the script that's running that's trying to reproduce our test cases. It's simplifying them and running them again. There's another screen, I think screen calls them tabs, that is trying to passing all these through GDB. So the fuzzer is still pretty bad. The start of this video, for people who go back and watch it, is actually me going, I shouldn't use stir copy when I don't actually know how big of the things I'm copying are. Um, but so at least some of these that aren't reproducing are not reproducing because I'm causing a my test harness is causing a seg fault when it stir copies a really large function over the end of a page. But in case that's what we're doing, we're trying to reproduce everything. Well, right now we're reproducing things and classifying them, and right now, so what's the best thing to do here? So right now we have at least a handful of cases that we know are unique. These are cases which are we're going to need to track down exactly what is going on. So what's going to be the best way to handle this? Oh, I didn't think about that one. One thing that's interesting here is because we're running all these in GDB, GDB is going to handle ASLR for us. So we don't have to worry about things like ASLR causing repeated PCs or non-repeated PCs. They're going to be unique for us because we're running it in GDB. Look at that. But I think what we're going to do here is, so the first four that are listed there, these four right here, these are all, printing out is killing stuff on me. But so those four are still in Python when we crash, which means that we should have a backtrace that's at least somewhat plausible. So let's go take a look at those first. So we're gonna grab this one. So the PyDict get item one, I'm not super hopeful about. I suspect it is probably a not a red herring, but it's not going to be a useful crash at all. I suspect it's just something that isn't initialized. What I'm hoping for, and we're going to see if that hope plays out, is that one of these is going to just give us PC in something useful. Okay, I like the way this looks. GDB dash dash args, dash dash args, bang bang. So we are in the Py. So we're moving something around. We're moving from a -1, a 32-bit integer -1. Okay. For people who didn't catch that, I just moved around my screen. We're going to let the other stuff run in the background for a while we actually try and investigate some of these crashes. Repro. So, this is the thing that we're actually testing. What I'm really hopeful for. So, I really hope that's the case. So if you notice, RSI is actually the integer value we're passing in here. There's no way it's that easy. Right? No, there's no way it works that easy. Makedir test. We're going to cp ec2 repro that into test this. Okay, so we're in here. Like, there's no way that I can come in here and go 414 on 4 on 4 on 4 on. Okay, that's kind of promising. What the crap are you doing? This is a real thing? int as buffer is apparently going to just straight up convert that to a pointer. What on earth is... So right now, I am absolutely shocked that this is not working entirely. Like, that is... Wow. Four two, 4-2, 4-2. Huh. Like, ah. Why is it doing that? Okay. So we're going to go find out what this function is supposed to be doing. There is an undocumented function which takes a C-types pointer. Why is this a thing? The answer is this function takes an integer from Python and just straight up uses it as a pointer to get data out of. Okay. Creating numpy arrays from a C-types pointer object is a problem. Wow. Oh yeah, that's a good point. Import numpy help numpy dot. What the crap is this? Thanks. Okay. It is actually mind-boggling to me that this is... I mean, I guess it's not... It's not that surprising. Like, numpy is supposed to be math stuff to be more efficient. And I guess it's only one direction. Not the band. The copy is one direction. Int as buff. Fine. Well, that did not give me what I wanted. So we import it. It's a thing. Converts an integer to a void pointer in Python. Can I give a thumbs up on I really would like to give a thumbs up to this comment right now. Where are my emoji reactions? I would like to have them. This seems like an absolutely bizarre thing to have in the oh hey, look at this. This was 9 days ago. Like this seems like the kind of thing that going away probably is a good idea. Because why would you do that? Yep, that's not what I want. I want move around in here, don't I? There we go. Well, okay, there's enough complaining about that now. Unfortunately, it appears that that one is not quite as exciting as I was hoping it would be. How about this one? This one is right here. So while we're at this, let's do a little bit of cleaning up here. So, bang. We're going to move crash int as buffer.py. We also want to move ec2 repro / this thing here. Let's take a look at what it looks like. Oh. What is this thing doing? Ooh, this isn't hash. This isn't. Oh, this is still an as buffer. This is almost certainly going to be like we're mem copying stuff around, aren't we? Yeah, this is the same thing. That's unfortunate. I was hoping this would be something. Okay. Next one. So that was those two. Let's take a look at this one real quick. Rid of that one. EC2 repro this one. Oop. 5, 8, 9. This one right here. What does this one look like? Ooh. Load text. I can buy that thing. We are getting. Oh. No. This is still int as buffer. That is super unfortunate. It would appear that all of these are based off of the same thing. Not quite sure why this one is calling pystring from string in size as opposed to from buffer. My guess is that it's because of the number of arguments, but okay. Well, the good news is we still have all of these to take a look at. So let's go hunting for these. Six, 7, 6. RM that thing. E from E repro. This thing in here. What does this look like? No, I do not want to see this. Stop it. Because this one is also why do you hate me? All of these int as buffer problems. Okay. So the good news is that we know that if we were to continue fuzzing, which depending on how things go, we may or may not continue. we know that int as buffer is something we should exclude from our fuzz cases. Aha, this one does not have int as buffer. This one is actually unique, maybe. So, what are we looking at? RSI is interesting. That looks to me like a partial pointer override or something, right? So we called np negative get field. We called get field on np negative. Okay, so this is exciting. We finally have one that looks like it might be, something new. Import numpy as np. np dot negative dot get field. This is getting called with a float. And it's getting called with a np.int c. So what's this crash look like again? So this looks like, what does that look like? This looks like a heap to me, right? So this looks like it was all Fs. And I'm not sure how this high bit got set, but like that definitely looks like a heap pointer. This looks like it's a negative heap pointer almost. Meow. We have get field there. We called int c. So let's go the other direction here. np.int c. That gets called with np.log add expression with np.short with no arguments, np.uint_p. That worked fine. 2 to 32. Is equal to that. Then if we do np negative 32 dot get field np dot float 16 comma a. Helps so I can type, doesn't it? Data type not understood. So clearly I'm doing something wrong here, right? 2 to 32. Yeah, that's the right value. Oh, that's 2 to 32 plus 1. Does that matter? Plus 1. So int c of this thing, that's load add expression, this thing, which is np short, this thing, which is uint p. Okay, we did that. Then we're calling negative 2 to the 32 dot get field negative 2 to the 32 dot get field np dot float 16 comma a. Ooh. So like it's that entire thing. Oh, did I call float 16? Ow. Interesting. So what does get field do? Import numpy as np help np.negative get. Ooh. Not implemented virtual attribute. Class generic exists solely to derive numpy scalars from and possesses, albeit unimplemented, all the attributes of the ND array class so as to provide a uniform API. What? Half those words don't make sense to me. Okay. So let's think a little bit more about what's going on here. My gut feeling here is that get field is what's causing a problem. Like we're trying to get a field. So the fact that it's a float 16 matters. So where is this? This? Oh, crap. 7? Oh. It's interesting that it's kind of crashing the same spot. Like it's getting the same thing. Hmm. Like that totally looks. No, it doesn't. I'm lying. So get field on anything, according to you, I thought you're going to bed. Something about it being 1 a.m. So it looks like get field with, oh, so the second argument matters. It doesn't crash for low values. Okay, we're gonna go figure out what this thing actually does. Get field. Get field. It's claiming to just be a generic method. Okay. We've come back over here. Do a backtrace here. I wish I had full symbols. I kind of want to go get full symbols for this. So I have some Python symbols. I don't have numpy Python symbols. How easy is that to get? You know what? I think what I should do here at this point is build a. So if I build a debug build of numpy, I would get all the symbols, and I can use that to actually take a look at stuff. Oh wow, it is already 9 o'clock here. Hmm. You know what? It's actually late enough at this point. I think, unfortunately, I'm going to call it an evening now. It looks like we have. Man, we've got more of those memcopy crashes. I'd like to go look at these. but I think the best thing to do right about now is to call it an evening, and we can pick this back up next Wednesday. The good news is we have crashes. We have several different unique crashes. At the very least, we have three crash. At the very least, we have three crashes that we know of right now, and we haven't gotten into the other ones yet. Like we still haven't tried to do. Why didn't we? Why didn't we start with some of these asserts? So we're gonna have to go through and triage all of these, but this is a pretty reasonable number, right? So we've got 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, about 30 it looks like unique PCs right now. And have we finished this? Yeah, it looks like we're more or less finished at this point. MGDX, rerun this. Looks like 30, maybe 40 unique crashes are what we have right now. I think it's a reasonable enough number that we're going to be able to go through most of these, and we can probably root cause all of them. So I think that's probably going to be the next few weeks, is going through root causing as many of these as possible. But at this point, we're probably going to call it an evening for today. I still cannot believe that there is a numpy function which is straight up pass in an integer and it will then read data out of it for you. Like in terms of an exploitation primitive, that's pretty great. Being able to just read arbitrary memory might come in a ton of handy or ton of use later, but we'll find out later. So thanks everybody for tuning in today. I probably won't take much of a look at these until next Wednesday. So we're going to drop right back in here and have all these crashes to dig through. So I will see you all next week. And just as a note, because I didn't do this at the start, for people who are interested in the CTFing, there is CTF this weekend. There is RCTF, which is the Royos CTF. It's one of the XCTF competitions. So, should be exciting. Yeah. Thanks everybody for tuning in. Have fun if you decide to play the CTF this weekend. And in either case, I will be here on Monday, hopefully solving, going through some of the challenges from our CTF from this weekend. So, thanks everybody for tuning in, and I will see everybody later. Bye.